Welcome back to Probability and Statistics. In this short video, I want to explore using Desmos and its basic pseudo-random number generator. In particular, what I want to do is basically create a pseudo-random number generator modeling uniform random variables, use that generator and generate 10,000 simulated observations of a uniformly distributed random variable, uniform on 0, 1. And then create a histogram of those observations to verify that they are indeed uniformly distributed on 0, 1. And here we'll just kind of verify that visually by comparing the histogram to the density function that we would expect for a uniform random variable on 0, 1. So let's take a look. Just going to go over to my web browser and pop open a new tab and go to Desmos and go to the graphing calculator. So to begin with, we need to create the generator, and I'm just going to do that one step at a time here. Actually, I kind of like to document what I'm doing as I write these little sheets with comments. So I'm going to add a note just to create a uniform generator on the interval from 0 to 1. So we want our generator to produce values that are uniformly distributed on 0, 1. The way to do that is to create a uniform distribution object in Desmos. So I'm going to call that object D. We say equals, and then you type uniform dist for uniform distribution, and then you give it the interval that you want that distribution to be supported on. So this is, we want the uniform distribution on the interval from 0 to 1. You notice Desmos automatically plots the PDF of that distribution. We don't really need that, so I'm going to turn it off by clicking on that button. But we do now have the generator. So D is an object that models the uniform distribution on 0, 1. It can do a lot of things, including print the PDF or plot the PDF. But what we want to do is actually generate observations from that distribution. So we want to sample from the uniform distribution on 0, 1. And actually we want to do that multiple times. I'm going to get 10,000 samples from this distribution. Here's how to do that in Desmos. Let me call those samples Y. And then I would just say, take my uniform distribution, which I've called D, and then say dot, and then random. That's the random sampling function. And then you need to tell it how many samples to take. We want 10,000. 10,000 is the maximum size of a list in Desmos, and what the generator is going to do is put these 10,000 observations from a uniform distribution into a list, so the maximum number we can have in Desmos is 10,000. Notice it's telling me that Y is now a 10,000 element list. That list contains my uniform observations. For instance, if I said Y and then square brackets 1, that's my first observation, about 0.667. Y2 is my second observation, about 0.058, and so on. The second to the last observation, Y of 9,999 is that, and my last observation would be the 0.0507. So that's how the generator works. It puts those values in a list. What we'd now like to do is make a histogram of those values and see if they look like they're roughly distributed uniformly on the interval from 0, 1. That's real easy to do in Desmos. Just type the word histogram. Give it the list that contains the data you're interested in, so that's Y. And then give it a bin width, which we'll call 0.1. There's a couple of options down here that we need to be aware of. The bar heights, you have a choice of making the heights either the count of observations that are in that bar, or the frequency of observations that are in that bar, like the relative proportion, or they have a density option, and that's really the one we want to take. I'm going to press that. What that does is just scale the histogram so that its total area is 1. And this makes it easy to compare the histogram to the density curve that it should be, close to. You also have another alignment called bin alignment, and that's about whether you want your bins, how you want your bins placed. The bin width that I've chosen here is 0.1. And I've got the center bin alignment, which means that all the bins are centered at integer multiples of 0.1. So there'd be a bin centered at 0, there'd be a bin centered at 0.1, there'd be a bin centered at 0.2, and so on. You can also elect to have the left endpoint of a bin at the particular place. So this would have the left endpoint of a bin there would be a bin with a left endpoint of 0, a bin with a left endpoint of 0.1, a bin with a left endpoint of 0.2, and so on. Doesn't really matter too much for this particular case what we choose. There you see the histogram. We would want to zoom in on this a little bit, right? Because all the action here is going on, all the values of y are between 0 and 1, and it looks like all my bars are around 1 unit high. So if I go over here to the little graph settings tool, click on it, I'm going to make my x-axis hone in there from 0 to 1. Actually, I go from minus 0.1 up to 1.1. And then for my y-axis, I'll give myself just a little margin too, minus 0.1 up to, let's say, 1.5. And there we have it. So that was 10,000 observations from this uniform generator that's intended to model a uniform distribution on 0 to 1. You can see a couple of things. First of all, the bin heights here at the extremes look about half of what they ought to be. That's actually a function of the fact that we have our bin alignment set to center. So that very first bin is going to include observations from negative 0.5 up to positive 0.5 because it has a width of 0.1 and it's centered at 0. Of course, there's going to be no observations between negative 0.5 and 0 because a uniform distribution on 0 and 1 will only produce observations between 0 and 1. So we actually do want the left bin alignment option here, and that gives us something a little more reasonable, right? All the bins are indeed about 1 unit tall. Let me actually just draw the density curve as well. The density curve for a uniform distribution is, of course, just y equals 1, and that's for values of x that run between 0 and 1. So let me change that to a red color. So there you do see it looks like our pseudo-random number generator, D here, is producing values that are roughly uniformly distributed between 0 and 1. I mean, you could change the bin size a little bit and try to interrogate that further. So now I've got twice as many bins. Notice that all this is using this set of data that was generated here in step 3. I can ask Desmos to regenerate new observations. If I go up here to this little randomize icon, it looks like the shuffle icon in a music player. So if you just hit that, it'll go and generate 10,000 more observations and then make the histogram of those. And so you can see you do get a little variation around the density curve, but the bars are, you wouldn't expect the bars to be exactly flat, but they're very closely following that uniform distribution density curve. And so it looks at least visually like the uniform generator in Desmos is doing a good job of modeling a uniform distribution on 0 to 1. And of course, that's important for us because we will be using these distributions these uniform distributions to generate other simulate other random variables as well. So that's a quick idea about how to interrogate or investigate the uniform generator that's provided by Desmos. I will be following this with a short video to show how to interrogate other kinds of distributions. So I hope you found this helpful, and we'll see you back here real soon.